Hello, in this one we're going to talk about KUKA OLP add-on in Visual Components. My name is Samuli.
And my name is Keijo.
Alright Keijo, what is this KUKA OLP add-on and what does OLP stand for?
Well, OLP stands for Offline Programming, and what this add-on provides us is an executor that can interpret the native programming language of KUKA robots, which is the KRL. And it also provides us with the RCS behavior, which is capable of simulating the KUKA robot motions in an accurate way.
Okay, let's check first how to get started. So I'm running here Visual Components Premium 4.5. I don't see any KUKA specifics here. We first need to go to the backstage, options, add-on, and we can enable the KUKA OLP. It requires a license key. Once I have my key there, I'll just go ahead and activate. Then it says restart is required. I hit OK here and I'll go ahead and close this one and relaunch the 4.5 Premium. Alright, now the system is restarted and the first thing that we can notice, we have actually on the Home tab a new panel called Devices. Keijo, what is this Devices?
Well, this is related to the robot system for KUKA robots, and here you can do some configuration such as the safety configuration for KUKA robots.
All right. The most changes we will see on the Program tab, but to get started, let's actually load in a KUKA robot. So I'll go down to KUKA robots. I'll double click on KR6 and it loads it in, but it also loads in a controller box. Or what should we call this, Keijo?
That's a feature in KUKA OLP that when you load a KUKA robot, it also loads a controller for that robot.
All right. And now if we go on the Program tab, we can see that if you are familiar with the Visual Components editor, this editor looks a little bit different now, and it's specific for KUKA robots. Just for the fun of it, let's see how it behaves if we take an ABB robot arm and we go back to the Program tab. And now we see a little bit different type of program editor. So this is the Visual Components program editor, which is the same for all robot brands, but now with the KUKA OLP add-on enabled, the KUKA robots will use the specific KUKA editor. The basic use is somewhat similar, but as we will see in this one, there's quite a lot of new features in this one. But I'll go ahead and create a little test environment. So I will take from the e-catalog conveyors, a little conveyor. I'll make the width of it a little bit smaller. I'll take from flow components a feeder. And I will take robot positioners a little pedestal so that we can just elevate the robot a little bit higher. And let's take a table Let's learn to spell table. Make this a little bit smaller, like so. And I change it to aluminum in color. The last thing, I will take a end of arm tool from Shunk, a little 3-finger gripper, and I will make it a little bit bigger for a 150mm product. Right on, let's test it out that we have some parts. Oh, one last addition. We will need
the sensor.
the sensor, exactly, thanks. So that we stop the parts here. Let's test it out and hit play. Alright, something weird's happening here, generating something. What is this, Keijo?
Well, the KUKA robots have this RCS module now. So what it needs is a robot system, and this dialog shows that when you run the simulation for the first time, application will create the robot system, or what we call the machine data for that robot. And the application does that automatically, and you see that dialog being prompted there.
All right. So that's just happening automatically for you in the background.
Yes, and it will also take into consideration things like external access devices. So if you were to have a KUKA linear unit or a workpiece positioner, it would create the machine data for those devices as well.
All right. And now when I run it again, I see that it doesn't do it all the time. So it's done once, and after each major changes, it might do it again, right?
Yes. If you configure the layout, like change the relative position of workpiece positioner against the robot, you might see the machine data being generated again.
Alrighty. Okay, I'll do some signal connection here. So we want to get some inputs and outputs for the robot. So sensor Boolean signal goes to the input, and I will say that it goes to the input 100, and the power on signal goes to the output 100. So basically from this robot output 100, I can control if the conveyor is on or off, and I can wait input 100 if there's a sensor, if there's a part on the sensor or not. So that's that. Let's dive now into the program editor. And I already added a couple of positions here, so I will get rid of those. But yeah, this workflow is somewhat similar to the Visual Components editor. In the same fashion, you can modify tool center point data, for example. So I will modify my tool center point to be there. And now I can jog the robot from there. I can add, for example, a little approach point here and teacher point. And now we can test it out. There we go. Let's make this product a little bit bigger coming from here. So I go into the process tab and I'll edit my products. And I make my cylinder radius 75 so it matches with my gripper. Go back to the program tab and let's create statements. Wait for 100. Input 100 to go high, and after that set output 100 to go low, basically to go false. All right, so with this one, we wait that there's a part at this sensor, and in this one, we are turning off the conveyor. But yeah, let's actually copy and paste this one, and in the beginning of our program, let's put the conveyor running, so setting output 100 true. Nice. Now we have the part there, and I will actually with control drag location of the approach point, and I will touch it up. So notice that the touch up you will find from the right click and touch up. Then I will take the robot position down here. I will add a linear motion and back up to retract. And in this position we would like to grasp the part, and for that you can use similar approach as with Visual Components Editor. Set output 1 to true, which is by default already pre-configured to do grasp and release. So let's now test it out real quick. Beautiful, it works as expected.
Yes.
To finish it up, I'll just put it on the table. I add a linear motion here, an approach, which in this case I put PTP, and retract a linear, and make it in a better order, like so. I can click them through, just click here, click here, click here, then down there and up there. And again, down here, we would like to release the part, so I'll go and set output statement properties 1 to false. Is this, by the way, case sensitive? Do I need to use caps or can I use small?
No, I think it is case sensitive.
All right, so let's respect the KUKA language habits here.
Yes.
Beautiful, it works. All right, I understood that there's a lot more, and maybe you could show a little bit more.
Sure. I can show a couple of things that are new to this KRL add-on. So here you did the conveyor control in the old-fashioned way, where you program the I/O in the robot program's main thread. But what's nice in KUKA robots and the KUKA OLP add-on is that you can have background programs on your robots, and these are called submits. And you can create a new submit if you go to the program and right-click there and click submit, add submit. And let me rename this conveyor control. So this basically creates a new program that is run in the background of the robot executor. But I also need to enable that submit, and you can do that by going to the simulation configuration on the gear icon, and here you see some of the settings for the RCS controller, and at the bottom you see the configured submits, and the first one is the default SPS submit, but I can put my custom conveyor control on submit 2. And let's close this editor now.
So this basically means that you have two parallel programs running, the conveyor control and the main.
Yes, and the difference is that in main you can program motions for the robot, but in the background task you can have logic like usually some kind of I/O statements there. And what I'll do in this case is I'll build my conveyor control logic on the background program. So let's show the conveyor control program on the editor. So I right click and click this show button here. And the default submit structure looks like this. And what I'll do is I'll create some I/O statements in this loop that is run on the submit. So let's navigate to the I/O statements, inputs and outputs, and let's set output. And here, let's select the output port 100. And let's write the value. And here you can use the KRL syntax, which is very familiar to structured text in code-sys programming. So what I'll do is say that my output 100 is not, which is the inverse of the system input $in 100. So the input signal 100. So when there's nothing in the sensor, the motor is running, and when sensor gets a hit, the motor is turned off. And we could also place a small timer on the loop to give some breathing room for the execution. So that's, I have a hundredth of a second delay between the loop cycles.
All right, so this is maybe a little bit closer to kind of like a PLC type of programming in that sense.
Yes, and some of you may have done this with robots in Visual Components layouts have like a separate robot to run just some kind of logical program.
Mm-hmm.
But yeah, that's my background program, and now let's go to the main program. And now we don't need these output 100 statements anymore because the conveyor is controlled by the background task. And let's go ahead and delete these. In my main, now I only wait for the signal from the sensor, and the robot should do the same big tasks as before. But let's test if the background program works or not.
Yeah, I can see. And now maybe the main benefit in this one would be...
Yeah, the benefit for this is that while your main program may be still processing the previous part, doing the motions there, your background program can already handle the next part. So using the conventional way of having both in one thread can cause problems like the next part arriving at the sensor while your previous part is still being dropped on the table.
I see.
Yes. So what else can we do in the KRL? Well, we can show a little bit of expert KRL programming. So what we could do in this example is make the robot stack multiple parts on the table. And conventionally in Visual Components, what you could use is use the base shift technique there. But with KRL, you can actually modify the position variables to do this. So let's do that, shall we? And first, let me program a loop in the main routine. So let's say my loop starts here. So in KUKA, you can have a while true loop, or there's a endless loop also that you can use. And let's create the loop and place all of our process statements to handle the parts inside the loop. Okay, and now we can take a look at the KRL view. So we have this tree view by default enabled, but we can view the actual KRL code by enabling this KRL view. So this is the program language that the KUKA robots actually execute. And you can do programming in the KRL editor itself.
So now this is an actual text editor that we see here.
Yes. If you're familiar with KUKA robots and have done commissioning with work visual software, this editor is actually very similar to the work visual editor and has most of the same features that you have in the work visual editor. But let's have it so that in my programmed routine, I drop the part on this position variable xp4. And let's make it so that the drop position is being shifted for every loop cycle. And for that, let me create a new position variable. So program data you can view on this other view called data view. And here you see some of the variables that have been created automatically. And for example, the E6 boss is a data type for the robot positions. And what we can do is create new variables of that type and use that in our KRL code. But for this kind of temporary variable, I'll do the declaration in the program itself. So at the header of main, I'll declare my E6 boss, and I will call it XP4 shifted. So what I had previously is the XP4, but now I'll have a new variable. And before I go to my work cycle or the loop, I'll initialize that variable with the programmed position XP4. So it just copies the value of XP4 to XP4 shifted. And here, instead of moving to the XP4, let me just type that we move to the XP4 shifted.
Can you expand the editor a little bit wider so that we can see?
Sure. The KRL statements can be quite long, and the default view doesn't show all the arguments shown here.
I can see, yeah.
And after we've done one cycle, let's modify the XP4 shifted and its Z components a little bit. So I'll type that the XP4 shifted .z is XP4 shifted plus the height of the product, which I remember being 100 millimeters. Let's see if I'm right. And now let's run the program again. And you can have the editor either in the KRL view or the tree view while you're running the simulation.
Nice.
Yes.
That was fairly straightforward way to create a stack.
Yes, indeed. The KRL editor offers a lot of flexibility when doing the programming, and that's what the KUKA OLP add-on does it for you.
Now, if you shift back to the statement view, is it then up to date?
Yes, the two views should be synchronized automatically. So if I shift it back and take a look how it looks in the loop, you see that some of the codes that I wrote in the KRL editor, like the shifting of the XP4, is shown here as like a assign statements in the tree view.
Okay, and seems like this is now the true robot program code already, so this doesn't necessarily need to be translated like post-processed because it is already robot code, right?
Yes, you don't need to post-process because the code is there, but the question might be that how do I extract it from this simulation model? And there's this tab, KRL programs. In order to export the KRL, let's select the program we want to export and click Export KRL. Now I'll select this location, just select the folder, and that should export my KRL program to that location. And if we take a look what was created, typically the KUKA programs consist of two files, the src and dot file. So the dot file contains the data for the program, and the src is the actual program, so the motions and IO statements and so on.
All right, nice, thank you. I think this covers the basics of the KUKA OLP add-on. In order to learn more, you can visit the help, where you can find the help file for the visual components stuff, and then this button is only showing after you have enabled the KUKA OLP add-on, and this will take you to the KUKA programming specifics. So, but maybe we want to say that thank you for watching, and stay tuned for next one. Thank you, Keijo.
Thank you, Samuli.